Hi, I'm Dr. John Grayzel. I'm an applied anthropologist. I worked for approximately 30 years in international development, then became the Baha'i Chair for World Peace at the University of Maryland, and now am deeply involved with the International Society for the Comparative Study of Civilization. I provide this just so you'll know my biases, not my credentials. As you will see, bias plays a role in how we explain things. And how we explain things create our biases. Willie Nelson, famous American country music singer, comes up to near where I live for an annual concert. And he always sings a song, which is, well, it's sad but true, but someday it'll happen to you. Your can-do can't keep up with your want-to. Without going into a full analysis of Willie Nelson, let me say that he is 89, and the International Society for the Comparative Study of Civilization is 61. So we're in better shape than Willie Nelson. But we're still not in that good shape. We too suffer from it's sad but true, and someday it'll happen to you, that your can-do won't keep up with your want-to. Our can-do is all the understandings, information, insights, and thinking that has gone into the study of civilization. The can-do is how we use actually our methodologies to discover, portray, and here's my bias as an applied anthropologist, actually address imperative problems. Our want-to-do is strong, but somehow our can-do is not that strong. And the reason I'm going to propose today is because the methodologies and approaches we use to discover and describe and compare civilizations are not up to the pressing challenges and tasks of today, which include actually getting out of all the information we've collected what we need in terms of understandings and actual proposals for action. So that's what I'm going to talk about today. Now, fortunately, I believe we actually have a solution on the horizon. And the solution is in quantum mechanics, quantum theory, and quantum computing. Now, quantum theory and quantum mechanics have been around for quite some time. Quantum computing is just beginning to be developed as a practical tool. 10 years, 20 years, but it will be there. And I'm going to explain to you why I think it will solve our problems and actually change the trajectory of civilization itself. I can't spend a lot of time explaining quantum mechanics very quickly. Basically, quantum mechanics says reality on the subatomic level is sometimes expressed by particles and sometimes expressed by waves. Sounds very simple, though. How did I even get interested in this? Well, ironically, my interest started many years ago. As an anthropologist, I studied a people in Africa called the Fulani. The Fulani are an incredible group of people. They're herders, and they stretch across West Africa. And they look very different from the agricultural populations, and for years people have tried to explain where they came from. Lost tribes of Israel, migrations in prehistoric times. My research revealed was that the Fulani actually, when tested genetically, correspond to the local populations of which around whom they live. In fact, the Fulani is a role. It's not actually an identity or a position. It's a way of presentation of self. They actually have a term for it called playing the Fulani. If you read National Geographic, for a long time, one of their favorite pictures are of these Fulani men that look like they're dressed up sort of strangely. They're supposed to be women in that, but they look sort of a little bit crazy. And I always wonder what people think. What these are young men who once a year put on a show in which they imitate the girls. Because in Fulani society, physical attractiveness is one of the key factors for identifying yourself as a Fulani. So once a year they turn it around and they dress up with the girls, and the girls sit around and clap and choose who the prettiest boy is. When I studied this more, I realized that this was part of a much larger process. That the Fulani didn't come from somewhere, they come from where they are. But over time, agricultural people who have cattle and begin to give up regular agriculture change their identity from farmers to herders to protect their wealth, basically. And that the process was one of dynamic movement of identity, not specific identity. So when you lived among them, you realize people were constantly trying to say, well, he's a real Fulani. No, he's not really. He's sort of a Fulani. They didn't have the type of solid identity that a single particle would. And their identity didn't come with them from somewhere else, but the identity, the Fulani identity, almost as an energy waves, spread over West Africa as people took up herding. When I had to explain this, actually, what I decided was most relevant was called the Heisenberg principle. Werner Heisenberg said you cannot measure velocity and position at the same time. If you're at a racetrack and want to study the car, you have to stop it. That's the end of the race. If the race is speeding around, you can't quite see the car. So you always are interfering with reality when you measure it. And that reality sometimes is a particle standing still or a wave, energy moving across. And that's something that we're going to have to remember carefully. Particles are substances made out of energy itself, but concentrated enough that it takes physical space. Waves are energy that is passed along in motion. So a tidal wave, when it starts here and ends here, the water hasn't moved. What's moved is the energy in the water as it begins vibrating from some cause, like a volcanic eruption. It's hard to believe, but this phenomenon now offers us tremendous hope for being able to totally change our relationship with information and data and our ability to deal with the complexities of the world. And I'm going to talk about the two ways this is going to come together. One, through what I call, which is called artificial intelligence, and the other, which is called quantum thinking. And I'm going to explain how they'll help us. I'm going to explain how I believe they're going to change civilization from a phenomenon that we see as multiple civilizations, often in conflict, to an understanding that we have one global civilization, and that what we see as conflict is when it fails in what its true purpose is, which is harmonization. What is civilization? First, let's be clear, civilization isn't a thing. It's a thought. It's a way we see things and a way we express them. And it can be as simple or as complex as our own minds. This is the challenge. In our normal life, we try to simplify things. And that's how we hope to deal with complex situations. The same has been done with the study of civilization. People have said, oh, what's civilization? It's cities, when people began living in cities. What's civilization? When people began to have certain codes of behavior. What's civilization? Monuments, complex systems, complex social stratification. In fact, it's all of these things, not any one of them. But to deal with all of these things, we usually go through a process of reductionism, where we create what we call externalities and focus on what we want to focus on. That's how we do it, because otherwise we say it's just too complex. So we live in a world, normally, that is often described as Newtonian, that things seem to obey laws. What goes up must go down. They're formulas. They're fairly simplistic. They're linear. This happens, then this. They're not that complex, though underneath it all, they may be difficult to understand. But is that real life? Real life, at least mine, complex, complicated, filled with multiple clashing factors, ever-changing, evolving, going in all different directions. So what happens when you take Newtonian thinking and apply it to real life? Well, I don't know if any of you out there ever used Match.com to find a significant other, but sometimes it works and sometimes it doesn't. You have simple determinants or traits that people try to use to say who's compatible, but the truth is, compatibility is a very complex, fluid, and hard to capture dynamic. But we're going to be able, I am proposing, to do something else. There are two technologies that will help us escape from the world of Newtonian thinking into the world of quantum thinking. The world of quantum thinking, as we see, is very different and actually was developed because when you get to the subatomic level, the Newtonian laws don't even apply anymore. So now the question is, are there other dimensions in which the Newtonian laws don't apply as well? And are we actually not talking about other realities, not just metaphors or analogies? So what are these two technologies? The first is artificial intelligence. Artificial intelligence is basically using computers to mimic human thinking. Instead of programming them to just rapidly do what a human being has figured out they think they should do, they are programmed to actually go through not only a decision-making process, but potentially a discovery process by which they can discover for themselves answers that you don't know about from the data. There, the question is mainly one of enormous increases in the speed by which we can make decisions and enormous increases in the reliability of our making decisions. So, for instance, artificial intelligence can be used in medicine. It's been shown over and over. An artificial intelligence run machine can diagnose eye problems much more accurately than a living doctor. It knows all the factors, it can recognize them, it doesn't get tired, it works for hours, it works well. Behind it all is the mind of a doctor, but one is taking advantage of the efficiency of artificial intelligence. This is somewhat different than quantum computing. Quantum computing actually replaces, a simplistic description, actually replaces electronic silicon transistors with subatomic particles that can be programmed in multiple ways so that they function much like on-off, but there are multiple numbers of them on a single subatomic particle. The result is that a subatomic particle, a quantum computer, can study, compare, question, and analyze a multiplicity of things at the same time. This results in enormous increases of speed and the ability to do tasks that just would be impossible otherwise. Simplistically, a regular computer, it can read a phone book, it would do it line by line, and then compare line by line. A quantum computer can read the entire phone book all at once and compare everything. And if it's in a language you don't understand, it can also translate it at the same time. This creates enormous increases in speed. Virtually the possibility of us, anytime we want, accessing the total amount of human knowledge that we have that we can store in a form accessible by a computer. So again, speed is a big factor, but it's not the most important factor. In the world of quantum computing and quantum physics, there are new dynamics occurring that in the real relationship between facts and phenomena. I'm going to discuss 4 of them, which I think would change our whole view of civilization. The first one is called superposition. What superposition means is that there are many positions at the same time, not one. So it's not only that you can analyze multiplicities of things at the same time, but your explanations can have multiple dimensions. It's not, oh, is it urban? Is it a code? Is it information? It's all those things. They are superimposed on each other, and one has to understand them. Those are the waves. We may decide to focus on one as a particle, but the reality is they are all together. The second one is called entanglement. Einstein called this spooky change at a distance, because what happens is once any 2 particles have affected each other, we discover that they are affected forever, even if they are separated by millions of miles. This has tremendous implications in terms of human relationships, which are established and then we think go away or end. But what entanglement means is once you're connected forever. The third one is that observation actually changes what we know and what is. So it is when we want to measure something that it becomes the reality we call it. It's when we want to take that energy bundle and measure it that we create a particle. And it gets changed based upon how we measure it, which is really not that hard, I think, to believe when you realize that we measure things, say, different than a bat. A bat measures things by sound wave. A bat never sees what we see. We don't see generally what a bat sees. So the observer changes things as well. But the last one is perhaps the most important. The other 3 affect how we understand what we are dealing with and measuring. The 4th is extremely interesting. It's called interference. I have a pair of headphones at home. They cancel out noise. They send out a wave that intercepts waves of sound and creates silence. They interfere with each other. Let me just read you something. In quantum computing, the whole idea is just to choreograph a pattern of interference where the paths leading to wrong answers interfere destructively and cancel out, while the paths leading to the right answer reinforce each other. You know what that says to me? That says to me, we get rid of lies and we distill the truth. If we can do that, what an amazing change and progress in thinking will that occur? What will be the functional consequences of this? That's sort of the theoretical background. Now let's look at what could be the functional consequences. To begin with, it's just what we said. We'll have truth rather than lies presented to us as the data itself. Second, rather than the diversity and separation of sort of traditional reductionist thinking, we will accept and realize the inseparability of interdependence as the reality itself. Third, if we actually have computers that can do this, it means that almost anybody will actually have the same power to access the totality of human information. The priest, the professor, The doctor. Yes, we still have room for specialists, but we will be able to actually access all the information they have and theoretically ask the same questions and thereby get the same results. And I also have a fourth dimension, which I believe it will allow us to address what I call reality on the spiritual level as well as the material level. Because of our present level of Newtonian analysis, we tend to believe everything is material. But quantum computers allow us to go to the most fundamental questions and the most expansive inquiry. And I believe will even allow us to clarify what our individual as well as group purposes in life are. That's what I mean by spiritual. Clarifying, addressing, responding to the most fundamental purposes of our lives, our communities, and our societies. Why is this important? Well, let's just go back for a second and talk about civilization. Civilization can be looked at as just an explanation, but it has also been looked at as a phenomenon called the superorganic. And that means it's a phenomenon itself, and it transcends the individual lives of individuals and groups, and it obeys its own laws. Now, the reason this is important for two reasons. One, it means we have to analyze that collection of all factors and data that are within what we might call the circle of any particular thing we call a civilization, not just one or the other. It also means that if we want to solve a problem, we have to go beyond our present understanding of the particular issue and place it in a larger context. By placing it in a larger context, it allows us to think of new relationships and ultimately new solutions. It's expansionist, it expands, it's inclusive, it embraces in the way that reductionism separates. In the way one man says, I'm a Jew, I'm a Muslim, I'm a Christian, and another person says, we're all members of Abrahamic religions, and another says, we're all children of God, and another says, we're all the results of something we have yet to understand. As we increase the circle, we increase what we can take into the circle. What will this mean for us as a society? It means that we can deal at the same time with unity and the need for common purpose and diversity of the phenomena within that common. Everyone doesn't have to think alike. Everyone doesn't have to be alike in order to have unity and harmony. They just have to harmonize. So what's that difference? Well, it's the difference between we're all doing our thing in a common way that allows us to harmonize, but the thing we are doing is different from each other. So it's really about harmonization. In the study of civilization, we have become totally fixated on conflict, and we don't really look at how do we produce harmonies. And yet, in the worst case scenario of the conflicts in the world, they represent a small percentage of the time and population of human dynamics that occur in the world. Most of the time, human beings are harmonizing with each other, or they could not work with each other. So why is this so important? It's not just about explanation and study. As an applied anthropologist, I have my bias. It's about addressing critical issues today that we have to draw a gigantic circle that takes in everyone in the world if we're going to solve them. Conflicts, climate change, unforeseen major disasters. We're going to have massive movements of population. We already are because of climate change, but also economics, social disintegration. And here's one that we're just beginning to think of. We are beginning to move into outer space. we will actually be migrating to outer space. And this is going to require us establishing totally new societies and peaceful and harmonious societies, or we won't succeed. So we have to master this art of harmonization. My next question is one that applies to our own society, the International Society for the Comparative Study of Civilization. We have a tradition of very deep scholarship in describing civilizations, attributing certain aspects to certain historic and social phenomena, and comparing them to each other, but usually comparing them in terms of similarities and different, not in terms of dynamics. But if civilization is going to change, don't what we study also need to change? Don't we have to begin identifying priorities for research, not just what we're interested in, but what's the most imperative need that we can contribute to solving? Don't we have to get above disciplinary and even multidisciplinary thinking to transdisciplinary thinking? Because the minute we are engaged in disciplinary thinking, we have frozen the wave into a static particle. And each of us uses a different instrument, and therefore we come out with a different reality. And we must actually show not only through research what is, but what we can do with our understanding of what is. Fortunately, the International Society for the Comparative Study of Civilization actually has opportunities already built in to do that. Opportunities that, going back to our Willie Nelson song, we want to do, but so far we don't seem that we've been able to do. Let me just give 3 examples. Andrew Targarski, who was one of our most enduring members, past president, and truly active intellect, has proposed that the only way we can have a sustainable Earth is by actually creating so expansive an information system that allows us to monitor all the elements that come together to create the complexities of global climate, and then to require us to adjust to them. He's actually an information expert, and therefore he has his model of what such an information system would look. But the fact is that it hasn't been put in place, and it probably, according to my way of thinking, will never be put in place as he presents it. He presents powerful arguments for the need and powerful arguments for the general response. But his information system is one built on expertise and multiple disciplines each contributing. And what we've seen already is that is not reality. We have to have a system that takes these factors and actually puts them in sort of the soup of reality from which we can extract them. It's the difference between a specialist who you go to and he tells you what's wrong with you, and a wise person you go to that helps you discover what the truth is for yourself and begin to deal with it. Classic computing is built on an expert telling you what to do through a computer that tells you faster. Quantum computing is about the information revealing possibilities based on your specific question. So that's one example we can use. Another is we have so much information from the study of civilization. We can't possibly now deal with it all, but we can if we have quantum computing and artificial intelligence. And what we will find, is that the factors that affect the reality of civilizations are not as obvious as we have thought, because many of them represent dynamics between small factors and not one particularly large factor, and dynamics over time as a wave rather than dynamics of a particular transaction. Now, people have tried to do this. They've drawn culture maps that try to say where different types of systems combine, but we haven't done it in a way that is systematic and can be used in all occasions with all information. We can do it with quantum computing. We actually have a past very active member of our society, Gordon Hughes, who's passed away, an anthropologist, who actually wanted to do this with the 15th century. He wanted to take all the information on all civilizations in the 15th century and show how they dynamically related to each other. He chose the 15th century because it's the first century where we really had global contact, so there's a lot of information, but it was less than we have thereafter. Today, there's over 10,000 pages of his work sitting at the University of Colorado with his initial observations, waiting for somebody to return to actually extract from them all they have to tell us. It will happen when we have quantum computers that can do it. The third area is another member of the International Society for Comparative Study, Greg Lewinsky. Now, Greg is particularly interested in the phenomena of Islam and Europe because Europe is under the process of transforming. The Islamic population of Europe is dramatically increasing, and it's not only going to increase as a percentage of the population, but the demographics are such is that it's going to concentrate itself in the younger population, while the classic Western population of Europe actually ages dramatically. What is going to be happening? People think what's happening, and it is in some way, is that this is a clash of civilizations. But, these civilizations have been together since time immemorial. The Ottoman Empire was in Europe. Europeans were in the Middle East. There were Muslims, and there was not necessarily the conflict that there is today. So this problem is in need of addressing, both for our understanding of why we move sometimes from accommodation and harmonization to conflict, as well as how we might be able to intercede and change situations of potential conflict into situations of harmonization. Now, to do this requires, though, among other things, acceptance and encouragement of a tremendous diversity of ideas. The ISCSC is actually trying now to greatly diversify its membership because it has been dominated by specialists of Western civilization and civilizations that Westerners encounter. And we have to increase it till it virtually encompasses representatives of every civilization. I say that with qualifications that I don't believe that these civilizations are actually independent civilizations, but they are reservoirs of domination of certain aspects of global situations. So that's going to help us. The key to doing this all is, again, though, to begin to release ourselves from disciplinary thinking, reductionist thinking, because we don't have to do it anymore. The quantum computer will do all the thinking with all the data. The key is, what questions are you going to ask it? Years ago, Einstein said he had a great problem, and he only had an hour to solve it. He spent 55 minutes identifying the problem and 5 minutes solving it. We have to get to another level of question making. This is actually a return in a way to Socratic thinking. Questions are where the answers really lie. In fact, without questions, there are no answers. And the time has come to do this for civilization itself. The greatest impediment to this, I suggest, and has been suggested, is actually, are we individually willing to accept new revelations from data? We tend to be so attached to specific explanations and understanding that we refuse to see the commonality. And an example I give, I see civilization much like the oceans of the world. Books tell you there are 5 oceans in the world. But if you look at them, they're all connected. The water flows through them. They're one ocean in which there are pieces of matter, land, placed, like floating ducks in a bathtub. If you put your duckies in the bathtub and your toys in the bathtub, you don't suddenly say there are 5 bathtubs. There's one bathtub and one water and things in it. The same with civilization. If you look at civilizations, they have always been connected. Some by narrow inlets, some by wide seas, some by changing over time. We are dealing with single phenomena and their subdivisions into elements of predomination. And so we have to be willing to deal with those and that diversity and the different perspectives that come from those diversities, which are all legitimate. So the real question I think that we have to ask ourselves always is, what's the most important question? And that's not easy to say. We can identify the problems, but it's not easy, and that's a challenge. And a question is not a rhetorical statement of what you really want to do or believe, as often represented. It's a real question about what is the most important thing I don't know that I have to know now. If we do this, quantum civilization thinkers, unlike Willie Nelson, can do and will do, and the world will be a better place. So in the end, what I'm saying is, when we actually get to understand, use, and the tools to actually master quantum thinking in the study of civilization, what we're going to find out, or what we know but we'll be able to accept and deal with, is there aren't multiple civilizations, there's one civilization. The same way as there are not multiple races in the world. There's only one race in the world, the human race. It has what are called clines, different genetic ratio populations based on where they're located and environmental adaptation. But there's only one race. Similarly, we'll discover there's only one civilization. That doesn't mean that you don't have to understand the dynamics of the subsets of that civilization, as we have to understand the dynamics of different genetic populations in solving medical problems and such. But there's only one human race, there's only one civilization. And waves are what really pass energy throughout systems, human, material, spiritual. We have to begin to look at waves. We don't have to look necessarily at people. There are waves of information, waves of thinking, waves of reaction that have crafted civilization and allowed them to affect each other, even at times that we have thought they've been separate and isolated. And there are also, and this one I think is very important for us in the West, the rational, scientific, academic oriented. There are different reasons to want to study civilization and to understand civilization. And we have to accept the legitimacy of that as well. And in that regard, I just want to end by just quoting to you what's a small Sufi statement by a well-known Sufi thinker of the 12th century that I think sums up why we have to study civilization. He said, "I heard it whispered in the cryptic streets, where every sage the same dumb shadow meets. We are but words fallen from the lips of time, which God, that we might understand, repeats."